Welcome back to Stithapragna, and you are watching the second video in season 6 where we are doing projects in networking role. And what is this playlist? AWS real-time projects for beginner to expert. And we are right now in the expert entry level. I think by the time we finish this season and next season, we will be an expert. And as promised, if you're following whatever I'm telling you to, by the time you finish all the 94 projects, so for this today's project is going to be 67, and we have still more projects to come. So by the time you finish all of them, you will have at least 4 years real-time experience as an AWS engineer. Got it? Okay, let's not waste any time, and let's go ahead and do our 67th project, which is about DNS query filtering. So we are going to learn about DNS today. So let's go ahead and select that. Oh, is it not in this? Okay, let's not do that then, because I can only do projects that this one actually shows. So which one do we do then? Okay, I think I already created all this. Okay, let's do inter-region peering. Inter-region peering. I think we can do this. Okay, let's go and select this one. This vehicle we ended in yesterday's class. Oh, that is fast. All right, so let's go ahead and learn about what this project is about. And again, this project is what? Inter-region peering. In previous class or previous project, we all learned about if you have more than one VPC, and if you want to connect those VPCs, we actually removed the peering and then created the transit gateway. Here we are going to create those peerings that we removed, I guess. So let's click on this person so that we can learn more about their issue. Hello, I'm the director at the space agency, and I lead a team that oversees our robotic spacecraft as they explore the surrounding planets. Thanks for coming. Nice to meet you. How can I help? Each spacecraft runs multiple software applications based on the target planet and mission type. Managing point-to-point connectivity without the ability to centrally manage the connections is costly. For that reason, we currently use AWS Transit Gateway as the central networking hub for our spacecraft. However, as the number of spacecraft grows, our missions will expand out across multiple solar systems. The space agency will need a solution to control communication between the spacecraft's applications across the galaxy. I see. With AWS Transit Gateway, you can quickly peer to or more transit gateways across regional boundaries. The service uses the Autonomous System Number or ASN to peer transit gateways. So now we are not peering VPCs, we are peering transit gateways. Awesome. You can create a peering attachment on your transit gateway and specify the remote transit gateway. After you create a peering attachment request, the director of the space agency in the remote solar system must accept the request. To route traffic between the transit gateways, you would add a static route to your transit gateway route table that points to the transit gateway peering attachment. I didn't know that AWS Transit Gateway could do that. It sounds exactly like what we need. I have one other request. While it is rare, a fleet of robotic spacecraft sometimes become self-aware and try to take down the network. Can we use Transit Gateway to block traffic to the fleet? Wow. I recommend finding the source of that problem. As it relates to AWS Transit Gateway, you can filter traffic to the fleet by using a black hole route in the transit gateway route table. The black hole route will drop traffic that matches the route. Perfect. Sounds like we are ready to move forward with this solution. Can you help us implement this solution? Of course I can. Great. I can't wait to see this in action. Okay. So um, I think I know that there is VPC peering, but I didn't know that there was a transit gateway peering as well. So I think it works the same way. VPC peering, how you connect is by pointing route table from one to other, etc. It looks like this is same as well. So by the time we finish this project, we will learn how to peer transit gateways between two regions, control and customize routing with AWS Transit Gateway, which we already did in the previous one. Create black hole routes in the primary transit gateway route table. This is something new we are going to do for this one. As usual, let's go see the video concepts, and here they are. I think we already covered this in the previous video. If you haven't watched the videos, and I highly recommend you to watch these, and these videos are available as part of this playlist that will pop here, which is AWS tutorials for beginners. Click on this link, it will take you to the playlist, search with this name, then watch all these 3 videos, and then come back and watch the remaining project. So let's click exit, and here we have our diagram steps. Let's go through them. This looks something similar to the previous one, but here we have two regions. Previous ones, whatever we did, all 4 VPs are in the same region, but here that's not the case. This solution uses AWS Transit Gateway to create and manage a single connection from central gateway to each spacecraft across the network, similar to the one that we had previously. Routing is built and configured with multiple levels of complexity. Finally, 2 transit gateways are pieced across the regional boundaries to show how to configure an inter-global network with transit gateways. 4 Amazon EC2 instances labeled host A through D, again similar to the last one, and each has its own VPC. Host A is in a public subnet and is used as the command host. A transit gateway is created in the primary region and is attached to the VPCs. A transit gateway is a network transit hub that interconnects attachments, VPCs and VPNs within the same account or across accounts, but in the same region. The primary region transit gateway is paired with a remote region transit gateway. AWS Transit Gateway uses the autonomous system number to peer with another transit gateway. Broader gateway protocol is the routing protocol used for peering. Black hole routes are created for subnets in VPC B and VPC D to filter network traffic. A black hole route in a transit gateway route table drops traffic that matches the route. In the DIY section, a black hole route for a subnet in VPC C is created. Okay. B and D they already created. C we are supposed to create it. Okay, let's click on plan. And as practice lab goals, we will peer transit gateways between 2 regions, control and customize routing with AWS Transit Gateway. Then we'll create black hole routes in the primary transit gateway route table. And as DIY, we are going to create black hole route in the VPC C. Okay, let's not waste any time and jump into the practice. Let's start the lab. And this one has a similar steps as the previous one, 43. As usual, read the concept. I'm not going to read it. Pause the video, read the concept, then move on to the next one. Okay, we are going to check. We are in the Virginia, North Virginia region, because this is going to be inter-region. So we are going to create or have the transit gateways in 2 regions. So make sure we are in North Virginia, and let's go to the EC2, and we are going to see the 4 EC2 servers that are already provisioned. So instances, and we are going to connect. We are going to do similar test that we did in some of the projects, and we are going to ping these IP addresses. So let me copy this. Okay, and I think this one is for VPC B, so obviously I think it will connect to it, and then we are also pinging 2.0 that is working, 3.0 that is working as well. So pretty much we are checking and everything is working, right? 2.0, 3, because they are all connected to each other using a transit gateway. Obviously they are going to work. Remember our first project in this season, that is what we did. So there is no surprise there. Okay, but they are trying with this one. This is what, VPCE. Does that even exist? Anyways, the VPCE, I am assuming this is in some other region. I think they are trying to ping that and it is not working. Understandable, because that is in a different region that doesn't come under this particular gateway. So we are going to go directly into the VPC. No more delays. and we are going to change the region now to see. I'm assuming the other VPC, Oregon. We are going to go to. Okay. And here we are seeing the transit gateway that is already created. So we are just copying the name of it. Okay, cool. And then we are going back to North Virginia and we are going to create transit gateway attachments. Okay. And we already learned how to create them. So we are good there. And we are going to name this, but previously these attachment were to a VPC, but I guess we are going to attach the transit gateway here using the attachments. Come on. Okay. And here obviously we'll select our primary transit gateway. Previously the attachment type was VPC, but here we are going to select peering connection. Then obviously it is going to ask us to enter peering connection attachment. Is it my account? Yes, it is. Where is it? Oregon. And then we are going to paste the copied transit gateway. Okay, once you create it, it is going to send a request to that one. So we need to switch to that account and then accept that request. This is something similar to VPC peering. We did it in one of the projects, maybe I don't remember the season, but yeah, we definitely did it. Same thing. We need to go into the other one account and then accept this request. So if you go to Oregon transit gateway attachment and if you click the action, accept the transit gateway attachment. Okay, so if you are watching from the beginning, this is not a new thing that we did. We this is something similar we already did, so no more. And once you did that, click accept. Now, as you can see, this is available, and we are still Oregon. Okay, we can go to our transit gateway route tables, which is right here. Then associations, and you can see. Oh, create association. Why won't it populate? Okay, we are going to associate again. Yeah, I think even for VPC peering, we have to uh, add the entry for the other one in the both. You have to go to the both VPCs and route it to the other one. So here also we are going to go to the uh, transit gateway route association, right? Then we will create it. And when you are creating it, what are you associating with? I think this is the transit gateway peering. As you can see, we are going to click that and create association. And then we are going to go to routes. And in the route, we are going to choose the default one, which is the 001. Then click actions, replace static route. Okay. 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 We did that. And what are they doing? Once you click on that replace static route, I guess we have to select the peering route again and replace the static route. And I hope you guys are reading the concepts. Once we do that, we are going to go to route tables, VPC route tables. The difference, that previous route table was transit gateway route table. This is VPC route table. We are going to click on VPC private. Then we are going to edit it. Okay. VPC route, VPC E. And we are going to type this one. So let me copy. And then we are going to choose the VPC E transit gateway that was created. Okay, so all we are saying is any IP address that comes in, send it to this particular transit gateway. And let's assume even if you are trying to uh, hit the one that is on the other transit gateway, you can still connect from here because this one is connected to that other transit gateway, so it can communicate with that one. All right, so that is done. Now let's go to transit gateway route again. Scroll, click. Oh, I don't know why they want to go there. What is there? Oh, this is available. That's it. That's what they want to check. Okay. Then we are switching back to Virginia and we are going to repeat the same things again. Select that associations, create association. Okay. And here we are going to select the remote one. And again, same thing. We are going to go to routes, create static route. And here we are not replacing anything. We are just creating static route, I guess. Okay. Static route and the IP address we are giving is this one, and obviously active. We are going to select that one. Create static route, and here it is. And then we are going to go to VPC routes, if I'm not wrong. Oh no, no VPC routes. Okay, we are again going back to A, connect to that, and now we are going to ping the E, and it will connect obviously without any problem. Now transit gateway route tables, and selecting that, click actions, create static route. Another static route? Why? What is this for? Oh, for the black hole. Okay. And do you remember what the black hole route is? So whichever seeder block you put in here, any anything, any IP address that comes from the seeder block, it is not going to connect it. So that's the point of black hole. You can prevent inter VPC communication by adding a black hole route for each VPC seeder block. Black hole routes in your transit gateway route table drop traffic. Okay, that matches the seeder block. Okay, makes sense. And we are going to create another one for something similar, which is 3.0. Okay, and I think if we go back and try to ping it, it won't be able to ping to those IP addresses. Makes sense. Got it. I think that's about it. I know there is too much stuff to learn here, but again, this is networking. It's expected. Networking usually is a separate role altogether. If you are a data engineer or developer, you won't have to deal with all this, but it doesn't hurt to learn. You don't have to be proficient at this, but if you at least remember how these things work, even if somebody asked you in the interview, I think we should be able to good. We can proudly say, I know how to do it. I did it. It might not be on top of my mind, but I did this and so on and so project, etc. We can say because we already know how to do it, right? So if we summarize this, let me try if we can, if I can summarize this without making a mistake. Correct me in the comments. We went to the EC2s and we connected to the connected to the EC2 instance A and tried to ping to B, C, D. It worked. E, it couldn't because the IP address E belonged to another region. So obviously it couldn't because we didn't connect the transit gateways yet. Then we went into the VPC and then we checked there is a VPC gateway, the primary one, and then we switched to the Oregon region, and then we went to the VPC there, and then we copied the ID, right? We copied the transit gateway ID from there, and we switched back, right? We switched back to the main one, and then what did we do? We attached, we created the transit gateway attachment. We went there and we, instead of attaching a VPC, we tried to attach the peering, and then we entered the copied transit gateway from the other one. Okay, and then it sent a request to the other one, Oregon one. So again we switched back to Oregon one, and then we accepted that request. And once we accepted the request, we went to the transit gateway route table and we created an association with the other or the primary transit gateway, and then we went into the transit gateway routes and we replaced the one with static and we selected the peering VPC. And then we went to the actual VPC route and we edited the route that already exists and added another role which said from 000 connected to this one. Then we switched to the Virginia one. Then we created a static route with a particular seeder block. And then we created another static route with a black hole where we entered two seeder blocks. Awesome. Now let's try to replicate what I just said. I hope I can. Okay, here we are. EC2, 4 instances. Let's pick this one. Connect. Session manager connect. Okay, let's try to ping 10.1.0.10. This is B, success. This is C, success. This is D, success. And this is E, which is in the other region, no success. Okay, that's all we want to test. Yes, we tested it successfully. I think that should be good enough. Let's go to Oregon and not EC2. Let's go to VPC. And let's go to transit gateways. I feel like by the time I finish doing all the projects in the network, I will be a pro at transit gateway and other things. Okay, we have this one. Okay, why are we here? Just to copy this ID. We'll be back. Let me copy it to something else. We'll be back to this again, but right now I just came here to do that. So let me try if I can open two different regions in two different tabs. I don't know if I can do that, but I'm just trying it. Let's see. Let me switch this to Virginia. Can I? Let me close the other ones. Oh, it closed it. Never mind. Okay, we are in North Virginia and let's go to the transit gateways. And we already know there is one, but we are not interested in that. Instead, we are going to attachments. We are going to create a new attachment and what do we name this? Let's name it remote VPCE because this VPCE is in the other region, that's why. So primary transit gateway we did in one of the project VPC, but here it is going to be peering connection. It is my account. Region is Oregon. I don't know why they are not showing by default, but this is the copied transit gateway ID. Pretty much that's it. And if you see initiation request, I don't know if that is what it is going to say. Anyways, let's go back to the Oregon. Attachments, so we are already there. Actions. Okay, it got the request. Select that. Did I create here? No, right? I created it there. Or maybe it takes some time. Okay, let's give it some time. Like the last project where when we created attachment, it took some time for it to come here. Okay, let's give it some time. And I think it should enable that accept thing. Yeah, okay, it did now. Okay, let's click on that accept transit gateway attachment. Yes, I want to accept. It's pending. I don't know why it is pending, because I'm the one accepted it. Maybe it will take some time. So let me pause and come back. Okay, it is available now. So once it is available, what is the next step that we have to do? Okay, we are going to go and create association. Where do you do that association? Go to transit gateway route tables, and we already have this route. So we are associating with this route. What are we associating? The other peering one, the peering one we created. So we are associating that. Okay, and then that is not the end of it. We need to replace the route as well. So select it, routes, and we have this 000 static. So we are going to click on it, and actions, replace static route. What are we replacing it with? The peering one. Instead of this one, we are going to replace it with the other one. So once we do that, we are going to go to the VPC routes. This is the VPC, sorry, not VPC, transit gateway routes. You have the routes table here. So let's go ahead. There should already be some routes created. So let's click on this one. Actions, or not actions. Let's go to routes, edit routes. Let's add a route. And we are going to give all this. And we are going to say transit gateway. And we are going to pick the VPC E1, which is nothing but the transit gateway for this particular account. So when it goes to that and we associated that with the other one, so it should be able to talk to the other one through here, and vice versa. I think pretty much that's it here. We are done. Now let's go back to the Virginia one, and we will try to repeat the same process. Ah, it is not there. I know. Don't worry about it, sweetheart. Um, let's go here and we'll go to the route tables, and then we have this. Okay, so associations, create association, peering, create association, done, select routes. Okay, we are not going to replace any of this because we don't have that 0 here. So let's create static table, and the seeder block is going to be this one. Okay, this is the seeder block of the VPCE. So that's what we are saying. Anything that comes into this, use the peering and connect to that one particular that VPC, right? That's what we are trying to do here. So we establish that here, and pretty much that's it. We will go to the click here, routes, and then let's create two static routes again. One is for copy this one. So instead of the active, we are going to create black hole. So anything that hits this seeder, we are going to drop the traffic. So let's go again, create static and paste it here, and then select 10.3 because that is another seeder we want to drop traffic, black hole, create static. So all that is done. You might be wondering like, oh, should we go to the route tables here and add something to these route tables? No, we are fine. We don't have to do anything here. Okay, because what is happening, why did we modify the route table there? Because imagine you are in this particular VPC A machine and you are trying to hit the VPC E. So that request, what happens, it will come here and it will check the route tables here, transit gateway route. Okay, and then it will like comes to the route, and then it is like it meets this one. So what did we attach? The peering, right? So it will, since the peering is established, it will go to the VPC. It will send the traffic to that particular VPC, and the initial routing table, it hits the routes there, and then as soon as it hits that one in the other region, then it will like, oh, this, then the associated um, the added ones, the route tables we added, right, in the VPC. We edited it and added for 0000 anything, go to the peering or the transit gateway. So it's like, oh, I got this. So I will send it to the peering routing or transit gateway, and the transit gateway through that it will give the connection, and hence everything works out. So now if I hit this should work without any problem. I mean, since our setup is correct, it is working. Now if I go and do this, it shouldn't, because I created a black hole route for this one. Same thing if I do it for 2, it should work because I didn't create a black hole route, so it should work. But 3, I created a black hole route, so that should not work as well. All right, so looks like everything so far what we did is working. So the practice, whatever we did, is awesome. Now all we have to do is create a black hole route in the primary transit gateway region table, route table for VPC-C. So what is VPC-C? 2.0. I mean, we can use that. But the thing is, I mean, are we going to block all of them? So then what is the point of using it? Okay, so I think using the route table, we will block them, but not sure why we are doing all that. Okay, let's go here and let's repeat the same process again. How do we do that? We go to the route tables. We select the transit gateway route table, routes, create static, and paste this one. This is the one too, by the way, and create black hole, create static. I think pretty much that's it. I think that should do it. Primary transit gateway ID. So let's go here and let's click on the transit gateways. And this is the transit gateway ID, at least the primary ones. And if I paste this here and validate, it should show green. If it doesn't, then I will be mad. And it didn't check. Could not find a gateway. Oh, sorry, it is asking the route table with the ID that you provided. Gateway route table. Could not find a gateway route table with the ID that you provided. But you asked for what? Primary transit gateway ID. Okay, let's go here. This is the gateway ID. I'm assuming I entered it correctly. Yeah. I am assuming they are talking about maybe route table ID. Maybe they missed it. I don't know. Let's see. I will just try it. Hmm, could not find a gateway route table. I think, oh, how come we came to Oregon? What? No wonder why it is failing. What? Did we have two windows? Oh, yeah, we have two windows, guys. Never mind. Okay, let me go here. I am getting the transit gateway from the other one. That's the problem. So I think if you copy this proper one, it will work out. But that's okay. No wonder. I was like, come on, even this one, I think this should work. I'm happy. Could not find a black hole route with subnet. Seriously? Don't tell me I created in the other one. Okay, this is making me mad now. One, two. Don't tell me I created that black hole here. Oh my God, that's why you should never have two windows open, guys. I think I created that black hole here. Yeah, I created it here. Oh wow. I mean, but I am happy about something, which is like I can figure out these things quickly. It's not like I'm taking forever to figure this out, right? I'm figuring this out ASAP. That is a good thing. I mean, we all make mistakes, but figuring them out is a skill. Trust me, that is a skill. And does it take time? Maybe. Okay. Yeah, it just takes some time. All right. I think that's about it. I'm happy. I learned. Okay. Uh, at least I'm learning few things here. Because previously, if you asked me about these things, I would be like, what gateway, what route table? I didn't even know there was a peering between transit gateways and etc. So, done. Your robotic spacecraft should be able to communicate across solar systems. This works great. Thank you for your help. Choose a reward. I don't know. I don't like any of this. I'm just choosing because they are not giving me any other option. Okay, and if you haven't liked and commented on this video, go ahead and do so because we are about to do our quiz. Get ready for it. And no cheating once again. Okay. I don't know. Every time this after the fireworks, it takes some time. I hope they improve this. Okay. That's that. Now let's do the quiz. How do we do the quiz? We zap drones. Where are you? Where are you guys? Oh, this is super fast. That's nice. Is it because I'm in space, but I don't see any blue ones? That's not good. Wow, all orange for some reason here. All right, are you guys ready? Transit Gateway supports dynamic routing protocols such as BGP. Yes, we know that it supports BGP. Again, no cheating. Leave your answers in the comments. We have to compare my score with your score. One love. All right, one love. Let's see who will win. What is the best description of an AWS Transit Gateway route table? A collection of rules used to control traffic routing between VPCs and on-premise? Nope. Configuration that enables a VPN connection between on-premise? Nope. A set of policies that determine how traffic flows within a VPC? A mechanism used to control traffic routing between different attachment connectors? I think it is this. You can choose whichever ones. My answer is D. And yes, too low. Again, no cheating. Oops, oops, don't go. In AWS Transit Gateway, black hole routes can be added manually to the Transit Gateway route table to block specific IP address. Yes, we just did it. Okay, pick your answer. And 3-0 so far. So good today. We are rocking. I'm rocking at least 3-0. I don't know about you guys. Let me know if you scored 3-0 as well. What is the benefit of using a transit gateway for network connectivity on AWS? It provides direct access to internet, removing nope. Streamlines network architecture by connecting VPCs and VPNs to a central hub. Provide dedicated private network connection between VPC. Nope. I think it is this. My option is C. So far my score is 3-0, and you have to enter your score as well in the comments. And it's going to be 4-0. You have to enter your answer in the comments by the time we finish with this one. Again, no cheating. What is true when peering across different regions in transit gateway? Peering is only possible with gateways that are owned by the same. Nope. Peering is possible across regions in transit gateway by using inter-region peering. That is the project I am now. Peering is only possible between transit gateways in the same region. Peering. Okay, do we call that as an option? Okay, I think I will pick that one. 5-0. Wow, not sure what's going on today, but definitely all my answers are right without even taking hints. Okay, I think that's about it, guys. 5-0. Enter your score in the comments. Users can add Redshift spectrum tables to multiple Redshift clusters and query the same data in S3 from any cluster in any AWS region. I don't think from any region, I don't think so. In the same AWS region. See that? I am correct. Anyways, if you answer this minus 6-0, post your scores in the comments. And I think I will end the video here. I won't do the architecture quiz. Maybe we'll do it in maybe next one or the next one. I don't know. But do post your score in the comments. Minus 6-0. We need to check ours. Okay? Because we both did the same project at the same time. So we have to see how much knowledge we gathered from it, right? So let me know. And thank you very much for spending your time and have a great day. See you in the next one. Peace out.